Large buildings brought the complexities of air conditioning to new levels with automated controls, a means by which large air conditioning units could maintain temperature, on-off control, and provide feedback as to current status with less oversight. Today, direct digital controls, or DDC, are to air conditions what cars have become to humans: indispensable. When it comes to HVAC controls, our goal is to control air movement and temperature and condition the air. This is a diagram that shows the air flow in this particular air conditioning system. Our arrow here shows the direction of air flow. That is, the air comes this direction. Right here you see RAT. This is return air temperature. This is where the air is coming from, the space, the room, the office, wherever. It comes into the air condition. This here is our fan, which is used to pull that air from the space. It's our return fan. The air comes into the air condition, comes down, and here's our other fan, which is a supply fan, which forces the air back to the space. This process continues as these fans continue to run. The fan is responsible for air flow. Other things to keep in mind are these dampers. These dampers would open and close to divert the air as we please. For example, as the return air comes back from the space, we have a spill damper that can spill. If it opens up, it gets rid of that old air. And here is our return damper. This will close down so as to force this return air to spill. Our other damper here is our outdoor air damper, which will open up and pull fresh outdoor air from outside right into the space. When we're controlling the airflow, we have the option of using the return air by modulating these dampers, or if we choose to, we can spill the old return air and simply use fresh outdoor air. It's recommended and required by law that these large air conditioning systems put in at least 20% outdoor air constantly to the space. Now let's talk a little bit about temperature control. Our return air temperature is 68 degrees, so we pull it across our return fan. Now if we're returning the air, it will come in this direction and head over to, here you see our heating coil, and it will continue to, we have here our cooling coil, and head out to the space. Now these two coils are responsible for the temperature control. If we need the temperature to be warmer in the space, then this coil will send our steam through and heat up the temperature as it passes across this particular coil, and then we'll have hot air going into the space. Of course, if we need the temperature to be lowered from this 68 degrees, then as it passes over this cooling coil, we'll open the valve and allow chilled water to run through the coil, which would decrease the temperature going across the coil and send cooler air to the space, which is exactly what's happening at this point. Just note the return air temperature is 67.6 degrees. It comes along. Of course, some of our air is being spilled and some comes across, and at this point the mixed air temperature is 58 degrees. So the air in this location is 58 degrees. Now, as it passes over the cooling coil, just take a look at our supply air temperature, 52.9 degrees. The temperature has dropped. So, we're using our cooling coil to drop the temperature and send it to the space. Air condition not only changes the temperature of the air, but it also conditions the air. It can add humidity, or we can dehumidify the air. To add humidity, we'd need a humidifier so as to put moisture into the air and make it soft as it enters the space. To dehumidify the air, what we'll do is, as the air passes across the cooling coil, warm air hits that cooling coil and the temperature drops. This also removes water from the air, thus dehumidifying the air, sending fresh, dry air into the space. The control must have the ability to maintain airflow, change temperature, and also condition the air. You notice down here to our right, we have what's called our set point. This unit is maintaining our supply air temperature. So what we'll do is we set a temperature for the supply air. Now, as the unit begins to fall off, as it begins to get too low, then it will close off on its cooling valve. As the temperature begins to get too warm, the unit will begin to open up on the cooling valve so as to drop that temperature. So the air conditioner is always trying to maintain that 55 degrees or whatever set point we put here. If it is winter and the temperature continues to drop below the set point, then our heating valve will begin to open up to provide heat. Now, you notice here we have our filter. We also have our pre-filter that catches the air as it returns or as it comes from outside. And we have final filter that makes sure it catches everything before it goes into the space. So in this way we condition the air, cleaning it, removing any particles that may be there. This is the basics of controls. Controlling the airflow, the temperature, conditioning the air through some type of control system that does it automatically.